Okay, let's take a quick look at these questions, which I'm hoping you found okay. It says a student holds a bar magnet. I need to make it bigger so I can see. Holds a bar magnet in each hand. If both hands are brought close together, will the force be attractive or repulsive if the magnets are held so that the two north poles, hopefully you said repulsive, north and south, hopefully you said attractive. And figure 24-7 shows 5 disc magnets floating above each other. The north pole on the topmost faces up. Which poles are on the top of the sides of the other magnet? So it's saying this is north, which means that must be south. And if it's repelling the one below it, that must be south, which means that must be north, which means the top one of the third one must be north. The bottom one is south, which means the top one of the fourth one must be south to repel it. Its bottom is north, so the top of the bottom one must be also a north. Okay? In Chapter 1, opening photo, page 2, assuming the north pole is the bottom face of the floating magnet, just looking for something to hold the page, what is the direction of the induced field in the superconducting disk? So over here, all the way over at the beginning, page 2. Oops, you don't have this. There we go. Now I forget what the question was. If the topmost was what? Assuming the north pole is the bottom face of the floating magnet. Bottom of the floating magnet. That means this must be the north. What do the field lines do? This is the north, this is the south. The field lines come out of the north and go into the south. Okay? I know, weird. And the last one, figure 24-3 shows a magnet attracting a nail so that to it, which in turn has attracted many small tacks to it. If the north pole of the permanent magnet is on top, which end of the nail is the north pole? If the north pole of the permanent magnet is on top, 24-3, I think it's back here somewhere. Here it is. If the north pole of the nail is on top, so that's north, so this would have to be south. And now I forget the question. It wants to know which end of the nail is the north pole. What? If the north pole of the permanent magnet is the top face, here. So this has to be the north pole because it's attracted to the south. All right, weird. At the end of the chapter, I asked you to do applying concepts. Applying concepts. A small bar magnet is hidden in a fixed position inside a tennis ball. Describe an experiment that you could do to find the location of the north and south pole. Well, you could take another bar magnet and move it around it to see what happens, or you could take a compass and do the same thing. A piece of metal is attracted to one pole of a large magnet. Describe how you could tell whether the metal is a temporary magnet or a permanent one. Well, if it's attracted, what could you do? Did you come up with something? You could move it. If it's a temporary, you could move your magnet to the other pole, and if it's also attracted to the same pole, it would be a temporary, right? Temporary ones will attract both. If it's a permanent, it would repel it down there. And I think I asked for 3 as well. Is the magnetic force the Earth exerts on a compass less than, equal to, or greater than the magnetic force that a compass needle exerts on the Earth? Boy, I'm hoping you're saying Newton's third law here. If one object exerts a force on another object, the other object must exert an equal and opposite force back. Okay? So that is the end of the homework questions. I'll do a separate video with the new stuff.